Okay, so we've talked about this open hole formation tester. It's type sample now. It is a bottom hole sample because it is taken at the bottom of the hole. Okay, so we do call it a bottom hole sample. But typically we don't use the term bottom hole sample because the third type of sample has been traditionally called the bottom hole sampler. Okay, so I'm going to differentiate. So I'll use the term MDT. I'm no salesman for Schlumberger for sure, but that's what we're talking about. So we've kind of gone through that, and now the next most common type of sampler or sample taken is what I call a surface separator sample, and then the last sample type I'll mention is a cased hole bottom hole sample. And in both cases here, they're cased hole, but basically we're now doing production testing at the surface. So we've cased the well usually. I mean, you can produce some formations without putting casing in, but it's unusual, okay? So basically the well's been ready for production to the surface, and you're going to actually do production test, and in connection with the production testing, during the production testing, you will be collecting the two types of samples, surface separator and or cased hole bottom hole. And I'll give you a little reason why you would pick the one versus the other, okay? So so let's just bring this down here. Okay. So we've got the the reservoir. We're flowing through the production tubing, which I'm going to make as a line to the surface. And then we're going to have a single separation piece of equipment, a single surface separator. It's going to be what we call a test separator, typically. It's for a single well. Big separators will often be for 5 wells or the entire field. Okay, those are production separators, much bigger and a lot more equipment. So these are specifically for testing a single well, and you have control of the separator temperature and separator pressure. You have some control over that. Let's see here. We have this here. And out of that separator comes a gas stream. And an oil stream. And there, of course, there could come water as well, but I'm ignoring that in connection with this discussion. So we're mainly interested in the separator oil. So we'll obviously be measuring the volumes of the separator oil. So I'm going to write it oil volume, and I'm going to use SP to indicate that it's an oil volume at separator pressure and separator temperature. It's not a stock tank oil volume. And the gas volume is actually a gas volume at standard conditions. Okay? They don't measure the physical volume at separator conditions. They report it as volumes at standard conditions. It's actually a orifice meter. It measures, I think, mass, and then they convert the mass to a standard volume. Okay? So that's what's measured. The two volumes here are reported as a gas-oil ratio, GOR. For the separator, it might be called just the symbol in the SPE is capital R is the symbol for gas-oil ratio. Okay? But typically I'll write probably GOR.
But how do you report GOR if it's not both in standard conditions?
Let me just do this. How they would report.
Like to me, like when you say GOR, it should be like both standard conditions. So
Yeah.
here they're using standard condition for gas and then separator condition for oil.
Yeah. So surface measurements of gas will always be reported at standard conditions. Always. Okay? You'll never see it reported at local pressure and temperature. Now, the standard condition of temperature may be a little different in different places in the world. I think Brazil has 20 degrees C, or I don't know. China probably has something different. But generally speaking, standard conditions here are 1 atmosphere and 60 degrees Fahrenheit. That's the official Society of Petroleum Engineers. But that doesn't matter. If you're in Brazil, it's, I think, 20 degrees C. So it could be 20 degrees C or something else. But this is kind of the standard. You'll see it, hopefully, in how they report the units. So the units of this would be, for example, standard cubic feet per sep barrel, written like that, or standard cubic meters per sep cubic meter. Some indication of whether the barrel or the oil volume is at separator conditions, or if they've done some tricky thing to take the separator oil down to stock tank conditions. You do have to be careful there, because what will happen is that periodically in this procedure, this will be continuous. These are continuous measurements. Continuous measurements with meters. So they're every 5 seconds, or I don't know what. It's always being measured. But every 3rd hour or every 12th hour, whenever the guy, has to go to the bathroom, or she has to, they'll take the oil, a little bit of the oil, for maybe 30 minutes, and they'll bring it down to stock tank conditions. Okay? So this is periodically during the testing. And they'll measure during that period a certain amount of stock tank oil volume corresponding together with the amount of separator oil volume during that 15 minutes. Okay, they fill up a tank, 100-barrel tank or something. And then with these two numbers here, during that period, they will give you what's called a shrinkage factor. Shrinkage factor. Okay. Of the separator oil, which is just delta the stock tank barrels per separator barrels. Okay? It's going to be less than 1. Shrinks. Oil shrinks. Gas comes out of solution. They don't measure the gas, but the oil will shrink. I guarantee you. Okay? And that shrinkage could be a number like 0.98, or it could be 0.7. Okay? Depends on a lot of things. Separator pressure, how light the oil is, whatever.
But then what about the solution gas that comes out?
They blow it off. they just go somewhere. I'm sure it's not controlled.
So it's not even added to.
Generally not. Okay. Then what they do is, typically you'll be. This is during a production test. So what they'll do is they'll be monitoring the separator GOR, okay, versus time. And this might be, 12 hours and 24 hours and whatever. It might be a 3-day test, different rates. But I'm just going to kind of show you, okay, is that this GOR during the early period here, this is what we call cleanup. Often they produce at a very high rate. There's a lot of water or mud. The metering is not very good, so maybe you've got a lot of scatter, like that. And then things start doing something like this, hopefully. Okay? So you see a stabilized gas-oil ratio. That's what you're shooting for. That's what you're looking for, is kind of a period of stabilized gas-oil ratio. Bang. We take a sample. Okay? So the kind of sample that we collect is basically there on the oil side, you've got the meter here. This is the meter. I think it's downstream to the meter. This is not my, there's a meter here. I think downstream to the meter, maybe it's upstream. I don't know. I'm not sure really. It probably matters, but I don't know. So you collect a sample, and this oil sample that you collect, you collect two of them. Two, I think they're like 600 cc volume containers, about. So I'm just going to say 600 cc, maybe it's short of a liter, samples of oil. Okay? And you collect two 20-liter samples of gas up here. Bigger containers, 20 liters, two of them. Okay? And why two? Because, if it can happen, it will happen. So one of them will probably leak or might leak, and so you don't want to, you can't go back to the well, 6 weeks later, the lab gets the container and says, oh, it looks like it leaked. Okay, so you get a, it's like a backup. Okay? And you make a note at that time of what is the separator temperature and what is the separator pressure at the time of sampling. And that's an important set of numbers for the laboratory to do things right. We're going to try to recombine these two samples, the gas and oil sample, together to get what actually is entering the well. So what we're going to get is our well stream. Now, whether the well stream reflects what's down in the reservoir, we don't know, right, completely. But we're going to get the well stream, because this is maybe perforated over, I don't know, it could be 100 meters. Perforation interval could be 10 meters, could be 5 meters. But it's like some average over that section where it's perforated. It could be anywhere from 5 to 100 meters. So what we're getting is some average reservoir composition in the well stream, and we're trying to reconstruct the well stream, what's here, by recombining the separator gas and the separator oil in the correct ratio. And to get that right, you need to know the separator pressure and temperature, the gas volume, the oil volume, and you need to make sure that the oil volume they're reporting is the separator oil volume. Okay? So what the lab needs to recombine physically the sep oil or the sep gas and the sep oil is the following. They need the following. One, they need the separator GOR. They need that in standard cubic feet per separator barrel, or standard cubic meters per separator, standard cubic meter, doesn't matter. But the point is that they need it with that volume unit of oil. They should not be given standard cubic feet per stock tank barrel. And if the testing company reports the oil volumes as stock tank barrels, you have to figure out what was the separator barrel. Okay? Nobody else but you. And if you don't do it right, you've screwed up. You didn't sit in my class. Okay? So if the testing company, and they do sometimes do this, sometimes they report stock tank oil volumes. Sometimes they just write barrels and you don't know. So you have to ask. If stock tank barrels are reported by the testing company, the testing company gives you every, I think it's 15 minutes, they give you a new line of data with gas rate, oil rate, at least every 15 minutes. And over a 48-hour test, it's a lot of rows of data. Maybe it's every 5 minutes, I don't know. And it says oil rate barrels per day. Then you don't know if it's separator barrels per day or stock tank barrels per day. And if the difference can be a factor of 0.7, it makes a difference. Okay? So, if you've got this thing here, like that, there's a lot of other columns I'm not giving you. But if it definitely says stock tank barrel, or the guy says it's stock tank barrel, then what you're going to have is way over here on that Excel sheet that you've got, which is like hundreds of rows long. It's big. Over here, you're going to have some kind of a comment column. And when the guy went to the bathroom, or she went to the bathroom and did this periodic shrinkage factor calculation, they will put over here as a comment shrinkage factor 0.826, maybe 0.83, okay? And then a little later, or 3, 8, 12, 15 hours later, they'll put another one, 0.712. Probably the separator pressure went much higher for some reason. And then maybe later they might have a shrinkage factor, what they report as 0.86, okay? If they've done that, so basically what's happened is that what they actually metered over here, they're not writing to you. They don't tell you. They don't report that. But in order to get the stock tank calculation that they have here, this is a function of time. Is what they actually meter as a function of time times the shrinkage factor, the current, in other words, they use this value here until they get a new one. Okay? So they're using 0.826 until they reach this row. Then they flip it to 0.712 and use it until they get 0.86. So this shrinkage factor, this is the current, I wouldn't say current, because that could be changing. It's the most recently measured. 6 hours ago or 8 hours ago, whenever it was. Okay? So if you really want to do the work properly, what you can do is that you can make it your own column, and you can add a column with the shrinkage factor, which will be constant, change, constant. And then you can just calculate your own column of separator oil rates. That's what you should do. The testing company should give you both, but they don't. Okay? And if you don't do it, if you don't understand it, then more than likely you'll get something screwed up by a factor of 0.7 or 0.9. I mean, by a factor that means something. What the lab wants is this GOR in standard cubic feet per separator barrel. So it's very important. Second thing they need to know is the separator pressure and temperature. This is related to a number of things. And I think that's pretty much it. Not all testing companies give you converted stock tank barrels, but they usually do. Some will actually give you the separator barrels, but you have to ask. It's not standard. Okay? All right, so that's the separator test. I don't think there's too much else I want to cover in detail. Yeah, I guess I could say, as an introduction to the last type of test, when is this not recommended, or when could this give, let's say, not good samples? Okay, there's a couple of situations. So basically, the SEP test samples can be used for oils, okay, for gas or gas condensates is okay. So any kind of reservoir fluid, it's okay. But possible problems would be in the situation, usually for an oil with solids precipitation. That would either be a wax or an asphaltene. Okay? Okay. Y'all know what waxes are? Is basically these, like, it's, well, you know what wax is, but I mean wax, petroleum wax will start with carbon numbers around C20 and go out to maybe C80 or something. They're straight chain alkanes, basically alkanes, mainly normal paraffins. And they precipitate because the temperature drops. The temperature driven precipitation. So this is temperature, low temperature driven. As the fluids flow into the tubing and go to the surface, temperatures start dropping, particularly in the surface facilities at the top, because it might be in the North Sea and the pipes get cold, and you start precipitating out this wax things. So the samples you collect, you would think intuitively, oh, we've had wax precipitation. You see this wax, sticking to the walls or something, and you think, oh, the material we collect has too little of these C20 to C80 normal paraffins. But in fact, you usually get excess, too much of these. You get too much of the wax paraffin. Somewhere or another in the sampling procedure, you suck in this excess wax precipitate. So it's too waxy, the samples that you collect. The point is that it's not representative. You don't have the right amount of these components. So the mixture is too waxy. So this is driven usually at the surface. And so the surface sample, the SEP oil, is wrong. Okay? It's either got too much or too little of these heavier components.
How would you know?
You'd have to make measurements of molecular weight and density, and then you'd see it. If it was too waxy, then the density would be too low relative to bottom hole samples. Okay? That's how you would see it. So you'd be comparing bottom hole samples where you don't have the wax precipitation going on versus surface samples where you do. And you just, because if it's too waxy, then the density is too low. So, and on the asphaltene, this is basically as the pressure in the fluid approaches the bubble point pressure around there. These mega molecules, asphaltenes, which are monster molecules, they can have molecular weights in the thousands, okay? They start precipitating out if you have enough of them. Now, North Sea doesn't have asphaltene problems, okay, in general. But some places in the world, if you have too much of these mega molecules in there, and your bubble point and your pressure approaches the bubble point, they can start precipitating out, okay? So that would be as if basically if the pressure drops towards and around and below the bubble point. So it's a pressure-driven process. Precipitation. Flow to the surface, you get a lot of pressure drops, so maybe you're going to start losing some of these asphaltenes, usually in the tubing. Okay? So if you have either of these, basically separator samples are not recommended. So. Otherwise, separator samples are generally good for any kind of system. The other nice thing about them is that you can get relatively large amounts of samples. I mean, it's not that much, it's not that costly. You'll have a double set. You can get if you need extra samples for some special PVT tests, you can get 4 bottles, or you can get, so it's you can get larger sample amounts at a relatively low cost. Okay. So that's kind of an upside.
For example, if we are taking the sample and the bottom hole fluid pressure is below the saturation pressure, so the sample that we take it's not representative, so we should use that sample for PVT?
Yeah, so the question is whether we should have a second thing on our possible problems. I guess I can put it there. Is that if the flowing bottom hole pressure, that's the flowing bottom hole pressure, drops below the saturation pressure of the in situ fluid. Okay? What happens? Well, near the well, you've got 2 phases, gas and oil, right? So that leads to 2 phases, gas plus oil, flowing in the near well region. So the problem is that the relative mobility of gas will be different than the relative mobility of oil. So that if gas comes out of solution from the oil, what could theoretically happen, it doesn't, almost never happens, is that you would think that the gas starts flowing faster than the oil, so the gas-oil ratio that you collect is not 500 cubic feet per barrel of what's in situ, but you might get 550 because you've got this local gas coming out of it. It doesn't happen that way for oil. Typically what will happen for an oil, if it should be a GOR of 500 cubic feet per barrel, you go below the bubble point, gas comes out of solution, it doesn't have much mobility, so you get 470 cubic feet per barrel. 480. You get something that's a little bit too low. Okay? So that the producing gas-oil ratio will typically be less than the initial, which is the solution gas-oil ratio for oils. Okay? But usually not too much. It's usually not a big issue. I mean,
For the very,
possible problems, generally speaking, it's not a big issue.
for very low GOR, probably it will not be, but for high GOR.
But even for high GORs, what you'll see is if you model these, and you should have a 1500 GOR, you might produce at 1460. It's generally not as big a problem as you think for oils. But the point is that usually it's going to be too low, a little bit too low. Okay? For gas condensates, then the GOR produced will be higher than the initial GOR, which is 1 over this, what we call black oil tables. We'll talk about it later. The solution oil gas ratio. So the initial gas oil ratio of the initial fluid, you'll produce at a GOR higher than that. And it might be anywhere from 2% higher to maybe 15% too high. Okay? What happens is the liquid drops out. It doesn't have any mobility. So you're losing this liquid, and it may take a while. It may take a week before you get enough oil mobility so the oil flows. So this is probably a more serious problem than this. I would say this is not really a problem for oils in general. So basically we have too little liquids, which is condensate, and here we've got a bit too little gas. Okay, so that is another potential problem. So the point is that in both cases, the recombined well stream composition, okay? The recombined well, when they put the two together in the producing GOR, may not be, it may only approximate the in situ reservoir composition that we're looking for, okay? That this would be the in situ composition that you'd like, and the well stream composition is just not quite right because the wrong gas oil ratio. Okay? But that's only if we need estimates of in situ composition. If we need PVT measurements, we don't really care if the composition here, we can use this for PVT measurements to get densities and things like that. It's sometimes it's not a big deal. Okay?
For example, if we will be using this and we will consider that this is our representative sample.
Well, in situ.
Yeah.
Well, if you have MDT type samples, then we can get the in situ composition accurately by decontamination. Okay. The other thing is that even if you hold the pressure above the dew point or above the bubble point, you may be producing from a section where there's compositional variation from top to bottom of the section. So all you're getting is an average anyway. Okay, it's not like these reservoirs contain a single composition everywhere. Right? So you're just getting an average.
But problem also occurs in the bottom hole samples, the MDT samples?
Maybe, maybe not. There are other problems in the bottom hole sample. Could be other problems. You're talking about C or A as bottom hole samples? The MDT or the A? Okay. It ends up these are not this for this is not a problem. This thing here is not a problem for MDT samples. Even if you go below the saturation pressure, it doesn't matter. For other reasons beyond, it's not a problem. Okay.
But based on these samples that we collected here, the saturation pressure and the properties that we calculate in the PVT experiments, so if we will use them in the simulation, the results that we will get, will that be representative of reservoir behavior?
Well, we're going to come back to that. I mean, the question is if the sample you collect is not in situ representative and you measure properties, densities, viscosities, etc., can you use those properties in your engineering work? And the answer is yes. Okay? So, but we'll come back to that discussion later. Okay, so that's basically the separator test type sample. It used to be the most common sample, even though it has some downsides. It's relatively simple to conduct and collect and use. Okay, any questions about that? That's the second type of sample.